Today we're going to look at coterminal and reference angles, but before we do that, we're going to do a quick review of some stuff that we learned from 10.1 and 10.2. So in 10.1, we learned about how we could use trig functions and inverse trig functions to solve for sides and angles in right triangles. So let's practice some of that right now. So we're solving for the missing side here and the two missing angles in this triangle. So if we wanted to start off by solving for the side, well, I noticed that we do have two other sides of the triangle, and so if we have at least two sides that we know the value of, we can get away with using the Pythagorean theorem. We could use a trig function if we really wanted to. It's your preference, your choice, but we could just as easily use the Pythagorean theorem. Okay, so those are the two legs, 9 and x, and the hypotenuse is 14. So I get 81. 14 squared gives me 196. 115, and then the square root of that is 10.7. So x equals 10.7. So there's our missing side, and I can easily add that in. So now I know that's 10.7. How then would I solve for missing angles? Okay, well, I can't use the triangle angle sum rule because I only know one of the angles and I don't know the other two, so I'm going to have to use an inverse trig function to solve for these angles. So let's say I want to solve for angle y first. Okay, I'm picking y to solve for first. So if that's my angle, I'm going to label my sides according to this angle. So this would be opposite, hypotenuse, and adjacent. Then I get to choose, because I have all three sides, I can choose whichever trig function that I like. So let's go with 9 and 14. I had those originally. So which trig function uses a and h? Well, hopefully you have this memorized. And you can write it at the top of your paper every time. So a and h would be cosine. So I'm using the inverse cosine. Inverse because I'm solving for an angle. So the inverse cosine. And for inverse trig function, I'm always inputting in the pair of sides, so ratio of two sides. So I have 9 over 14. And I am getting 49.99 degrees. I'm actually just going to round that up to 50 degrees. Okay, so rounded up, I get 50 degrees for this angle, meaning that z, okay, so y was 50, meaning that z has to be 40 degrees by the triangle angle sum rule. Okay, so we have 50, 40, and then 10.7. The next piece of this, so if we're going to draw these angles in standard position like we practiced in the last lesson. So here we have negative 6 pi over 5. In order to draw this, I just have to make sure that I convert it to degrees. So I have to multiply this by 180 divided by pi. The pi's cancel out. I have 6 times 180 divided by 5, which gives me 216 negative. Okay, so negative 216 degrees. So if you recall, so we'll use this first one to draw the negative 216 degrees. Negative values, I'm going clockwise, starting from the positive side of the x-axis, so that's my initial side, to rotate around this way to get all my negative values. So the first one I come up on is negative 90, then I have negative 180, and then negative 270. So negative 216 is somewhere here in between the two, and I just kind of roughly sketch it. It's probably somewhere about here. Okay. Then I draw my arrow of rotation, rotating clockwise to get to negative 216, okay? So always we can verify with that tool that I showed you yesterday, so negative 216, yep, right around in there. And then the next one, 650 degrees. So since this goes over 360, I know this is more than one rotation around. So let's subtract a rotation and see what we get there. So 650 minus 360, I get 290. Okay, so this tells me I do one full lap around and then I go 290 more degrees. Okay, and since this is positive, I'm going counterclockwise instead. So here's my initial side. I rotate one full rotation around and then go 290 degrees more. So for positive angles, I go 90, 180, 270, 360. So 290 would be right about there. So I'm going one full lap around, and then I continue another 270 degrees to get to 650 degrees. So one full lap around, then 270 more to get to 650. Or 290 more, 290 more. All right, so that's a review of those first two lessons. The first thing we'll look at are coterminal angles. So two angles are going to be coterminal if they are both drawn in standard position, which we've been practicing drawing just up here. So this is drawn in standard position. With each of their terminal sides, so if you recall, this side here is your terminal side, or this side that we drew there, that's your terminal side. The other two are your initial sides. So if each of their terminal sides are in the same location, the easiest way to find a coterminal angle is just to add or subtract 360 degrees. And remember from the last lesson we found out, okay, 360 degrees is the same thing as 2 pi in radians, okay? So 360, or if we're using radians, 2 pi from the given angle. So this will always give you an angle in the same spot that has simply been through a full rotation clockwise or counterclockwise, okay? So we're going to find 5 different angles that are coterminal to 120 degrees, okay? So all I have to do is, if it's in degrees, I take that angle, because theta is going to represent that angle, 120, and I just have to add 360 or subtract 360 from it. So 5 different angles that are coterminal to 120. So if I have 120, I just add 360 to it, I get 480. And I can continue to do this again. So if I take that 480, add another 360 to it, add another full rotation, I get 840. Okay, let's go backwards a little bit. So let's say we start at 120 again, and then we subtract 360. So I get negative 240, subtract 360 again, negative 600 degrees, and one more time, negative 960. Okay, so let's try to check all of these values. So 480 and 840. All right, so here I have 2 angles, because coterminal angles, it's talking about 2 separate angles. So if I plant this first one, so let's say this blue one, I'll put this at 120 degrees, okay? So an angle that would be coterminal to this one, its terminal side should land right on top of this blue terminal side there. So 120, that's definitely coterminal, it's just itself. But if I add 360, if I do a full rotation from where I am right here, so full rotation around, I get 480, which I just saw that I got a second ago. I do another full lap around, 840. I can continue going around. That's coterminal as well. Just as long as its terminal side lands right on top. And I could easily go the other way like I did. So those two angles are coterminal, so negative 240, negative 600, and negative 960, okay? So just by adding or subtracting 360, that's how we get all of our coterminal angles. And then now the next one, we're trying to do this in radians, okay, that are coterminal to 3 pi over 5. So probably the easiest thing to do, we used to have, if we were doing like math not in the coronavirus season, we had calculators that could really easily add and subtract radians for us. So I'm not going to have us worry about dealing with that right now. We can just turn this into degrees and then work on adding or subtracting 360 from it once it's in degrees, okay? So if we take 3 pi over 5, let's change it into degrees. 3 times 180 divided by 5, so that's 108 degrees, okay? And so from that angle, let's just add 360 to that. Okay, 468, 828, 1188. Let's go backwards a little bit. Negative 252. That's if I start at 108 and then subtract 360. And then one more time, negative 612. Okay. All right, so the next couple examples we'll look at, now we're just going to look at two angles and determine whether they are coterminal to each other or not, okay? So let's say we have 400 degrees and negative 680. So what we should be able to do is just add 360 or subtract 360 to get from either 400 to negative 680 or the other way around, okay? I just have to be able to add or subtract to get to this next number if they're coterminal. So let's try to start at 400 and then subtract 360 over and over and over again and see if we land on this number, okay? So 400 minus 360, I get 40 degrees. Okay, let's do that again. I get negative 320, getting closer, minus 360 again, I get negative 680, yes, okay? So if I do go back, if I do go backwards a couple rotations around, I do land on negative 680, so those are coterminal, so true, okay? And we can check over here if we want to. So what was this? 400 and negative 680. 400 is there. Come on, there you go. Okay. Negative 680. Yep, all right. They are definitely coterminal. Okay, and these next ones. So 7 pi over 9. If I convert that right now, so I just do 7 times 180 divided by 9. That gives me 140 degrees. And then the next one, 19 times 180 divided by 9 is 380, okay? All right, let's see if we could start at 140 and add our way up to this. So you might see right away, like if I take 140 and add 360 to that, right? I get 500 degrees, okay? So this angle, that's what I started at. I added 360, I got 500. So I'm not going to land on this angle. It's not coterminal to it. I should be able to add 360 and land on this angle. So if we verify that, 140 and 380. Let's go backwards here. So 140 was there. And 380, So 380 degrees. Yeah, it's not, it's starting to get there, but we need to add a lot more to it for it to land there on 140 degrees. Only 500 lands on that. Okay, so this would be false. They are not coterminal to each other. Okay. 3 times 180 divided by 8. I'm just converting these to degrees, so I get 67.5 degrees. Divided by 8, and 787.5 degrees. Okay, so let's start here and then add our 360. So 67.5 plus 360. Gives me 427.5. Okay, let's try it one more time. And I get 787.5. Bingo, that's what I want. Okay, so true, these are coterminal to each other.